Is going to be part 1 of the Unit 10 review. I think it'll take a little while to get through all these problems, so I'm going to split the video up into different parts. Maybe 2 parts, 3 parts, I'm not sure. We'll see how long it takes. Okay, our first shape here is a square pyramid, and the first thing it asks for is our lateral surface area. So I look to see what that formula is for lateral surface area. And I get the formula 1/2 PL. I'll just cover some of this up. Okay, so capital P stands for the perimeter of the base, and my base is 6, 6, 6, 6. So if I add those, I get 24. And then L is the slant height, and I didn't know the slant height, so I drew this triangle in. I knew this length is 3. That's half the length of the side of a base. And I did Pythagorean theorem to figure out my slant height, and I got 8.5 for my slant height. So I just plugged those numbers in, 24 into capital P, and 8.5 into the L, and when I work that out, I get 102 inches squared. Okay, then I want the total surface area. So it's the lateral surface area plus the area of the base. So I already know my 1/2 PL answer, that's 102. And then I have to add in the area of the base. Well, the base is 6 by 6, length times width, so 6 times 6 is 36. So I put my 1/2 PL, my lateral surface area answer right there, and I add the 36, and that makes 138 square inches. Okay, the last section is for volume. And because this is a pyramid, I go to the pyramid formula, which is 1/3 capital BH. Capital B stands for area of the base. The area of the base is 36, 6 times 6. And the height comes from the vertex. It comes straight down, hits in the middle of the base, and that height is 8. So 1/3 of 36 times 8, and that makes 96 cubic inches. Okay, moving on to our next shape. We have our triangular prism. And so first I write down the formula for lateral surface area, which is capital PH. Capital P stands for perimeter of the base. The triangle is my base. Those 2 triangles there are my bases. So perimeter of a triangle is all 3 sides added up. So 24 plus 18, because I know that there's 18. So 24 plus 18 plus this guy. So I had to do Pythagorean theorem to figure out this length here. And then I just add the 24, the 18, and the 30 to get my perimeter answer. And then that perimeter answer is 72. And the prism is 35 tall. And if I multiply that, I get 2520 square yards. Okay, total surface area. I take my lateral surface area and I add in the area of my 2 bases. So my lateral surface area, I got 2520, so that's going to go right there. Then I need to find the area of the base. So since my base is a triangle, I find area of a triangle by taking base times height divided by 2, or 1/2 base times height. So wherever that right angle is, the base and the height are always attached to it. So 24 is the base of the triangle, 18 is the height of the triangle, and I divide by 2. So this 216 right here is the area of my triangle, which is capital B, the area of my base. So I'm going to put 216 in to the capital B. And when I work that out, I get 2952. Okay, number 8 wants volume. And volume of a prism is capital BH. I just found the area of the base to be 216. So the 216 is going to go into the capital B. And then the height of the prism is 35. That's how tall the prism would stand if you stood it up on the triangular bottom. And that makes 7560 cubic yards. Okay, our next shape is a cylinder. The lateral surface area formula is 2 pi r h. I know the radius is 50, and I know the height is 20. So I know everything I need to know here. In terms of pi, the answer is 2,000 pi. And if you wrote it as a decimal, that is about 6,283.2 square feet. Okay, total surface area. I get by taking my lateral surface area and adding in the two bases, which are in the shape of a circle. So my 2 pi r(h) will get replaced with the 2,000 pi, and then I add in the area of these two circles, pi times radius squared times 2, and I already know the radius is 50. So 2 pi 50 squared, and when I work all that out, I get 7,000 pi. And if you give me a decimal, 21,991.1. Okay, volume of a cylinder is area of base times height. And then I find area of the base by taking pi times radius squared, so pi times 50 squared. And the height of the cylinder is 20. And when I work that out, I get 50,000 pi, which is approximately 157,079.6 cubic feet. Okay, there's our front page. Hopefully all is going well. Let's give it a little smiley face before we move on. Okay, next page. Our next shape that we have is a cone. Our formula for lateral surface area is pi RL. I know that the radius is 15, but I didn't know the slant height. So I had to do Pythagorean theorem to figure out my slant height, and I got my slant height to be 39. So it's going to be pi times the radius, 15, times my slant height, 39, and that makes 585 pi, which is about 1,837.8. Okay, total surface area. We'll take the lateral surface area and add in the area of the base, which is a circle, so pi r squared, and I already know my radius is 15. So I just put in my lateral surface area answer there, and then pi times my radius squared, and the radius is 15, and that makes 810 pi, or approximately 2,544.7. All right, volume is 1/3 area of the base times the height. And I find area of the base by taking pi r squared, so 1/3 pi times 15 squared, and the height is the 36. So 1/3 pi times 15 squared times 36, and that makes 2,700 pi, or approximately 8,482.3 cubic feet. Okay, next section is our sphere, and we do not have a lateral area formula for this, so we jump straight into the total surface area, and that is pi times radius squared, or 4 pi r squared, sorry. The radius is 6, so 4 pi times 6 squared, and then that makes 144 pi, or approximately 452.4 meters squared. Okay, volume is 4/3 pi r cubed. The radius is 6, so 4/3 pi times 6 cubed. And multiplying by 4/3 is the same thing as multiplying by 4 and dividing by 3, if you want to think of it that way. And that makes 288 pi, or approximately 904.8 meters cubed. Okay, our next shape. We have seen this shape so many times throughout this unit. It is the hexagonal prism, or the hexagonal, the hexagonal pyramid, or the hexagonal pyramid, however you like to say it. So total surface area is 1/2 PL plus capital B. So let's look at what we know. I know that capital P stands for the perimeter of the base. The base is this hexagon. So if all sides are 5, 5, 5, 5, 5, 5, 5, the perimeter would be 30. This 22 is the slant height. So I will have 1/2 of 30 times 22 there. Now I just have to work on capital B. Capital B stands for area of the base. And since my base is a regular polygon, I'm going to find the area of it by taking 1/2 AP. So, coming down to the drawing down here, I know that a whole side is 5. So when I draw in this triangle that this is 1/2 of 5, this is 2.5. To figure out what this angle is here, I take 360 and I divide by 6, because that's how many sides a hexagon has. 60 is the measure of the entire central angle, which is all of this. So 30 is half that. And if that's 30 and that's 90, this is 60. So across from the 30 is x, and across from the 60 is x square root of 3. So I know my apothem is 2.5 square root of 3. So when I go to find the area of my regular polygon, I use the formula 1/2 AP, 2.5 square root of 3, that's the apothem, and the perimeter is 30, because 5 plus 5 plus 5 plus 5 plus 5 plus 5 is 30. And that makes 37.5 square root of 3. And so that is capital B. So I replace capital B with the 37.5 square root of 3. If you keep your answer in simplest radical form, this is actually your answer. If you give me a decimal, it's approximately 395. And this would be units squared. I don't know what my units are here. Inches, meters, feet, I don't know. So I just say units squared. So hopefully this problem is getting easier because we have seen this hexagon numerous times. And we keep working with that 30, 60, 90. Okay, let's give another little smiley face. And move on to page 3. Okay. This next problem is talking about volume, and this is a hexagonal prism or a hexagonal prism. Our formula for volume of a prism is capital BH. Capital B stands for area of the base. Once again, my base is this hexagon, so I'm going to use 1/2 AP. I went ahead and I just drew in my picture. I know that since each side of the hexagon is 6, that this little piece right here is a 3. I just found out that this was the 30-degree angle in the last problem. So across from the 30 is the x, and across from the 60 would be x square root of 3. So that makes our apothem 3 square root of 3. And I know the perimeter is 36, because 6 plus 6 plus 6 plus 6 plus 6 plus 6 is 36. So this is capital B, 54 square root of 3. That's the area of my regular hexagon. So that's going to go in capital B. And then the height of the shape is 21.5. That's how tall the prism stands if you were to set it up on its hexagonal bottom. And all I have to do is multiply that, and that gives me approximately 2010.9 centimeters cubed. Now I didn't leave this one in terms of radicals. I didn't leave it in simplest radical form, so if you did that, I'm sorry. And all my calculators are gone, otherwise I would multiply that real quick for you. So hopefully you can tell if your answer is right or not. But this is the decimal approximation. Okay, next one. This is a triangular pyramid. And because it is a pyramid, I use the formula 1/3 capital BH. Capital B stands for area of the base, and my base is this triangle right here. And it says the sides of the base are 4 centimeters, so 4, 4, 4. And it says that the height is 8, so I know my height is 8. Okay, so to find the area of the triangle, I know your formula for area of a triangle is 1/2 base times height, or base times height divided by 2. And so I have to figure out the height. So I just took this triangle and I blew it up off to the side. And I could have done this with Pythagorean theorem Did I do it with Pythagorean theorem? No, I did it as a 30, 60, 90. But I could have done it with Pythagorean theorem. So I knew that this right here would represent the height. If that piece is 4, this is half of it, this is 2. I know because all sides are 4, it's an equilateral triangle, which means this angle is 60, this angle is 60, this whole angle here is 60. So I have a 30, 60, 90. Across from my 30 is x, across from my 60 is x squared to 3. But I could have done Pythagorean theorem. I didn't even think about it at the time I worked the problem, which would have been 2 squared plus x squared is 4 squared. So I could have done that. And then I know the height is 8. So here's my work for finding the area of the triangle. Area of the triangle is the base of the triangle, which is 4, times the height I just found, 2 square root of 3, divided by 2. And I did keep it in radical form. And I gave both answers, radical form and decimal. So 10.7 square root of 3, or approximately 18.5 cubic centimeters. Okay, the next one. I have a trapezoidal prism. Because it's a prism, I use capital PH to find the lateral surface area. Capital P stands for perimeter of the base, and I know my base is this trapezoid, so I just need to know what all the sides are. I knew this one was 24, I knew this one was 12. The problem is I didn't know these two sides. So I drew in this height and this height, and I know if it's 12 from here to here and the whole thing across the bottom is 24, that this piece and this piece have to add to be the remaining 12. So each of those pieces are 6. And then to figure out this, I do Pythagorean theorem. 6 squared plus 8 squared is x squared. And this is a 6, 8, 10 triangle. So this one over here is another 6, 8, 10 triangle. So to find the perimeter of the base, I add up the 24, the 10, the 12, the 10. And then if you stood this prism up on its trapezoidal bottom, 14 is its height. That's how tall it would stand. And 56 times 14 makes 784 square inches. Okay, our next one is a composite figure, and it asks for the surface area. So if I want to talk about surface area of this shape, I am talking about the surfaces I would paint. And if I was painting this object, I wouldn't paint the base of this cone, I wouldn't paint the base of this cone, and I wouldn't paint, as far as the cylinder is concerned, either of the bases. So this is what I would be doing. I would be painting 2 cones, but no bases at all. And I would paint the cylinder with no bases. Okay, so surface area of a cone is pi r L, and because I have 2 cones, that's why I have pi r L twice. Instead of 2 pi r L, I wrote it separately because the slant heights are different. So I can't just go 2 pi r L because there's 2 cones, and that's because the slant heights are different. So I'm going to do this cone and this cone. And then the formula for surface area of a cylinder with no bases, that's just the lateral surface area. So 2 pi r H. And then I just start plugging in everything I know. So this is pretty easy. Talking about the cones, the radius is 2. This cone has a slant height of 6. This cone has a slant height of 5. So one cone with a slant height of 6, one cone with a slant height of 5. Both have radius of 2. And that makes 10 pi plus 12 pi. As far as the cylinder is concerned, the radius of the cylinder is 2 and the height of the cylinder is 3. And when I work that out, that makes 12 pi. And if I add those, I get 34 pi, which is approximately 106.8 centimeters squared. Okay, we're going to stop this first video here, and then I will make a second video to finish the last 2 pages. Thank you.